Hello, everyone. I'm Norman Wahlberger, and I'm here with my colleague Daniel Mansfield at the University of New South Wales. And today we're going to start a small series of videos on a very interesting aspect of historical mathematics, going back a long time to 3,000 or even 4,000 years ago, to the time of the old Babylonians in Mesopotamia.
This is, I think, become one of our favorite subjects now. Just the unique mathematical culture that these people had is so far removed from the way we think that it gives us all these different insights and new insights into mathematics that we just wouldn't think of within our own culture. So it's so refreshing to actually look at this period of history and see something that we wouldn't normally see.
Yeah. And we're going to be moving towards a particular object that's especially of interest to us, which has the fancy sounding name of Plimpton 322, which is a very important historical artifact, perhaps the most famous of ancient historical mathematical artifacts.
Yeah. If not the most famous, then certainly the most sophisticated. I mean, we'll come to talk about this in quite some detail, but the level of sophistication on this tablet is just so far beyond any other contemporary tablet.
Yeah. And we are going to aim towards actually trying to reveal some new aspects of this tablet that we have together discovered through investigation in the last year and a half. It's been a very exciting journey.
It has taken us about 2 years, I think, to just put the pieces of the puzzle together. Most notably, this is an object that doesn't exist within our culture, so you really do have to get your head around some very different ways of thinking about things, such as numbers and triangles. It's taken us 2 years just to get our heads around it. So there'll be some new things that we'll have to explain very carefully, and we'll give you lots of examples. And hopefully by the end of it, we'll be able to look at this object, Plimpton 322, in a very new way and a very exciting way.
So maybe a good place to start is just to frame the general historical time, what was going on around, close to 2000 BC in southern Iraq, which is where most of these things are happening.
Yeah, the period we're talking about is technically called the Old Babylonian period, which is between 1900 BC to 1600 BC, and the object Plimpton comes from that latter half. It's been dated quite carefully to this end of the Old Babylonian period. What kind of things happened in the Old Babylonian period? Let's go there.
Yeah, I mean, it's fascinating because that, in fact, it's a long time ago, but in fact, that was really just the continuation of a pre-existing culture. There was the more ancient Sumerian and then Akkadian cultures that had been developing for really 1,000 years at least before the time period that we're talking about. And so that's going back to pretty well contemporary to the old dynasties in ancient Egypt. And I think it's really interesting also to compare the differences between the Egyptian culture and the Mesopotamian culture. There's lots of similarities, but also lots of important differences.
Yeah, the mathematical similarities are very interesting, and we'll cover that when we get to talking about the way they thought about triangles. Just coming back to the Sumerians, they had a very interesting number system, and so this is something we'll talk about in detail, but they counted... if I met a Sumerian, I would say they were excessively numerate, especially for a culture that was still in the early stages of developing writing. These people could count and they could do arithmetic in a way that I think would put most of us to shame. Maybe not you, but certainly put me to shame.
Probably a lot of us, because their ability to tackle really significant computations is little short of astounding.
Yes.
And often we see them doing these elaborate things. They show us the final end products, but the actual workings, it's a little bit mysterious how they do it.
Yeah, maybe we should talk about the evidence we have from this period, because in the Egyptian period we have these lovely, just epic monuments like the pyramid and the Sphinx. The Babylonians don't have monuments like this, unfortunately. They built their structures and temples out of mud. And the whole cities were made of mud, which is the material they had in abundance. And what would happen is a city would flourish, and then a drought, disease, or war would mean the city would be abandoned. And of course it's made of mud, the walls collapse, the roof falls in, and then when the war is over, or the famine is finished, or the waters return, the city becomes populated again, and they build a new city on top of the old city, out of mud. And so we have these piles of mud in the deserts of Iraq where the artifacts come from. And so archaeologists will dig in the mud and extract these things from a layer of this civilization.
Yeah. So this is all happening in the southern Iraq, where the Tigris and Euphrates rivers sort of come into the Persian Gulf. And in that area, I think a few thousand years ago, it would have been reasonably fertile. And certainly they grew abundance of crops, and they were able to support pretty elaborate cities with priestly castes and rich merchant class. There was trade, extensive trade in far-flung regions. They had agriculture, but the agriculture was also supported by irrigation, large-scale irrigation projects involving canals. They were avid,
Builders.
enthusiastic builders of canals.
Yeah, absolutely. And we know all this because of their writing. See, when they abandon their city, they leave behind all these things, but the writing was on these clay tablets. And if I was a merchant, I would keep records of my transactions under the floorboards. And of course, when the city was abandoned, these records would remain for thousands of years, up until the point where some archaeologist comes along and digs them out. And that's why we have such a detailed understanding of the nature of finance at this time, as well as the nature of their mathematics at this time. So maybe we should talk about scribal training as well. That's probably
Yes.
the most relevant.
That's very relevant to us. So they really had a respect for knowledge, and they had sort of like small universities or little colleges where maybe a group of people would be gathering together in a little home or maybe a larger place, and there would be a senior scribe, and they would get them to do all kinds of exercises. And we have remnants of a lot of sort of like schoolboy exercises of people doing simple problems and not so simple problems. And I think there was really definitely a culture of learning and a respect for knowledge. Literacy and numeracy were very highly regarded.
Yeah, and it's interesting when you read these things, you see not only this very unique culture, but its parallels with our own culture. So you can read poems about how you should stay in school and the benefits of studying mathematics and how it enriches your life. And it could as well be in a magazine today as in a scribal tablet 4,000 years ago.
And what I think perhaps is really also intriguing about this is that our understanding of this culture is, in fact, remarkably recent. People have been fascinated with the Egyptian culture for thousands of years because the evidence for that culture is so spectacular with the pyramids and all the temples and such. But most of the Mesopotamian remains were sort of buried for millennia and only really uncovered in the last 150 years. And so then there was sort of a sudden discovery that there was this ancient, long-lost culture that was really thriving around the same time as the Egyptians and in some ways was quite comparable to them in terms of sophistication and interest.
And in the primary interest was really around the turn of the century in the early 1900s, where archaeologists, mostly from Europe and America, would come in searching for artifacts. And they're searching for the big artifacts. They want the statues and the stuff made of gold.
Yeah.
The stuff that was written down is only now starting to become relevant. People are starting to translate these things and trying to understand what is actually written on them. And we've got a few examples here of the kind of writing that has been uncovered about 100 years ago, but is still being worked on today and actively translated and understood today. So we have a bunch of examples with us.
It's remarkable that there's really hundreds of thousands of these clay tablets around in various museums and collections around the world. Maybe you can't see this that well, but this is sort of some example. I guess the up's actually like this, say this one here, where you have these little cuneiform symbols. We'll discuss the sexagesimal system that they wrote in, but you can see that there's quite a lot of detail, and it's quite a fabulous project and challenge to try to figure out what these people were writing. You have to translate these ancient languages and then put yourself in the mindset of these ancient peoples.
Yeah.
You know?
It's a bit like a
It's very
puzzle as well,
interesting.
especially when the tablet is broken and you have to continue the pattern to see this missing fragment. We'll put a link in the description to the Cuneiform Digital Library Initiative, where you can see collections of mathematical texts and other Babylonian texts from museums all over the world in really high definition, and as well as links to the references translations of those tablets. So we'll put a link.
Yeah, we will do that. Now, for our story, so a lot of these tablets have a mathematical aspect, and we will talk about the mathematical side of things. But there's really one tablet in particular that really generated a huge amount of interest, and that's this Plimpton 322 that we're going to want to be looking at in some detail. And that really came to the fore in 1945 when it was published by a very prominent Austrian mathematical historian Otto Neugebauer and his assistant Sachs. But actually, before that, it already had quite an interesting history.
Yeah, before that, it was uncovered again in this early 1900s by an American archaeologist, Edgar Banks. Edgar Banks was this amazing fellow. He was a lecturer or professor, a diplomat, a obtainer and dealer in rare antiquities. He really is the real person upon which Indiana Jones was based. He even looks the same. They have the same hat. This is, he's quite a character. He obtained the tablet from one of his kind of obtainers of tablets and sold it to Arthur Plimpton, who was a book publisher and collector of mathematical texts from all over antiquity.
Yeah.
Plimpton bequeathed his collection of cuneiform texts to the University of Columbia.
And you've actually seen it.
And I've seen it. I've held it.
You've held it in your hands.
It's lovely. It's a nice kind of heavy tablet. I was terrified that it would crumble, but no.
You had to wear gloves.
You had to wear gloves, but it feels like a brick. Like this thing is very comforting in its weight. That was a lovely tablet. Plimpton didn't know that, of course. All Plimpton knew was that it contained numbers.
Yeah.
It really didn't become famous till well after Plimpton had died.
There's really only numbers. There's really 4 columns of numbers in this thing, and there's some headings. And the numbers are in their base 60 or sexagesimal system. And, on first glance, it looks just like some kind of accounting ledger or, inventory or something or other. And it would be similar to hundreds, if not thousands, of similar kinds of things. But Neugebauer and Sachs somehow realized that this was somehow different, and they really astonished the mathematical world. In 1945, they published a book which prominently showed that this tablet was, in fact, very, very special.
Very special indeed. So the first thing that really catapulted Plimpton into a new kind of almost category of its own is that it contains these numbers which we would recognize as Pythagorean triples. It contains a length, we might call it the short side of a triangle, and the diagonal of a triangle. And from those two things, they're integers, and you can compute the length of a triangle. And they're very special numbers. It's like to get a sense for what this is, it's like reading just a list of prime numbers. This is a very special sequence of numbers, and it completely stands out amongst all other tablets.
Yeah. The first one, for example, on the first row, I happen to remember it because I was just writing it down the other day. The 3 numbers are 119, 120, and 169. So that's a Pythagorean triple, but it's not, by anybody's estimation, an easy one. It's not one that's very familiar to people. But that's the one on row 1, and a lot of the other ones are even more complicated than that. So first of all, these people knew about Pythagoras' theorem. That's a pretty evident consequence of this. They had this relatively cool way of generating these things somehow, and they went through a lot of trouble to put these in a particular order on this particular table. There are 15 rows altogether.
Yeah, and it's the order, I think, that's really confused and intrigued people. This is not just some random list of Pythagorean triples. This is a very carefully ordered list of Pythagorean triples, and this is something that Neugebauer noticed. The triangles start off with something which we would call a 45-degree triangle, almost. The 119 and the 120 are almost equal, but then they steadily decrease at about 1 degree per line. And Neugebauer didn't make any claim as to what this could possibly be, but just that it was remarkable that they did this.
Yeah. And so since then, it has generated a lot of interest. So a lot of really great scholarship unraveling different aspects of this thing, because there's actually quite a lot of different things to think about. There turns out that there's a few errors on the tablet that are sort of in crucial places, and then people wonder, why are these errors there? What does that tell us about how the tablet was made and what it was for? And so there's been a lot of scholarship, but I think it's fair to say that there's still been a big mystery hanging over this thing for 60, 70 years now.
I do want to talk a bit more about the errors, and the completion of the tablet is where most of the attention has gone to, because you really have something concrete to work on here, and this is firmly within the archaeological traditions of understanding these tablets. If you have a tablet that is broken, you can try and spot the pattern within the tablet and thereby see the bits that are missing. This happened for Plimpton in the 1960s when this fellow D. Solar Price figured out what the pattern is on these rows, and by extending that pattern, he was able to figure out what should have been written on the reverse side.
Yeah, we have to understand that the Babylonians were quite efficient in their uses of these tablets. So it was not uncommon for them to write not just on one side, but to write also on the reverse.
Yep,
and sometimes they would even write on the sides, like there'd be a little bit of space on the bottom or the sides, and they could write there. And so it's kind of interesting that there are these lines that suggest that, as Daniel's saying, the scribe meant to write something, but for some reason he didn't get around to it. But it's intriguing, what should have been there and why.
And the errors also give us insight into how this could possibly have been created. And as we've come to understand more about this culture and the way they thought about numbers and the way they thought about shapes, even more recently we've been able to complete, this is not you and I, but we as a society have been able to complete the tablet and actually see what the likely contents of the missing fragment are as well. So it's really a huge amount of effort that has gone into trying to understand just what is on this tablet. It's hugely sophisticated, and it's taken over 70 years just to piece together the puzzle and try and understand what originally did this object look like.
Yeah. So I think that's what we're going to try to explain in the next couple of videos, is give a little bit more background about the arithmetical system, the way they thought about geometry, some of the scholarship that's gone into the tablet up till now. And then we want to present our own take on things. We have what we think is quite a spectacular new interpretation, I guess, of what this thing is for.
But it takes a bit of understanding, and you really need to get out of the present mathematical culture and into a Babylonian frame of mind to be able to see what is really on this.
So we'll be continuing, and we hope you'll join us for some more exciting old Babylonian mathematics.